Hi there, welcome to EDI or Direct Instruction on Mixtures, Solutions, and Compounds. Again, this is still part of the unit on the particle theory of matter. So, initially, we have here the classification of matter. So, our concern really would be on this part on the left side, the mixtures, the solution, and a little bit of intro on compounds. So this would be a big separate unit for grade 9. And then time permitting, we would be having a DI or direct instruction on the differences between colloids and suspensions. But for now, let's concentrate on mixtures, solutions, and compounds. Now, when you think about mixtures, think of soil. So sometimes it helps that way if you have one example in mind. So let's say soil is a mixture. Now, a shovelful of soil might contain some topsoil, some clay, maybe a little sand, a few bugs, maybe some really tiny microorganisms, maybe a worm, maybe some rotting plant roots, and maybe some more things. Now, these are some characteristics of a mixture. First, a mixture is not the same from one sample to the next, and a mixture can be separated into its parts. Also, on mixture, two or more substances that are not chemically combined, and it must be that they can be physically separated. Now, there are different ways of separating mixtures into its components, but this is probably what you are most familiar with. Filtering, right? You can separate large particles from smaller ones. Now, types of mixtures. There are two major types, heterogeneous, hetero meaning different, homogeneous, homo meaning the same. So, heterogeneous mixtures, you can see the different parts of the mixture easily. Whereas the other, you cannot see the different parts of the mixture. Now, sometimes visuals help really just bring the definition more clearer. So heterogeneous mixture. In this kind of mixture, you can distinguish all the components. Examples, if you have salad, fruit salad, paella, this is a Spanish dish, milk and cereals. In the morning, chickpeas, right? Homogeneous in this kind of mixture, you can't distinguish the components. Puree can be any fruit or vegetable, maybe. Coffee, because in coffee, especially if you have latte, you have milk, you have sugar, you have coffee beans, milkshake, and some of these other examples here. Now, in solutions, think of solutions as a different kind of mixture, but this time homogeneous, okay? So again, it pays to have an example in mind. So salt water, for instance, is a solution. So a glass full of salt water contains both salt and water. Now, we are putting two new words here, solute and solvent. Solute is what is being dissolved, and as to where it's being dissolved, we call it the solvent. And commonly, water is our universal solvent, meaning most of the substances can be dissolved in water. Now, salt water is a solution because it has these two characteristics. One, it has the same concentration of each of its parts throughout the solution. You scoop out maybe 1 tablespoonful of salt water, is exactly the same as another spoonful of the salt solution. And it can be separated by some physical process. Now, also still under solutions. So again, I said it's a mixture that appears to be a single substance. Material is evenly distributed by dissolving. Material must be soluble, able to dissolve. Solute is what is dissolved, as I mentioned earlier. Solvent is what the solute is dissolved in. And water, as always, remains to be our universal solvent. Now, on the idea of compounds, think of the chemical formula. Water is a compound. It is made up of hydrogen and oxygen. And you are familiar with the chemical formula, H2O. Remember, this is the subscript. It tells us about the number of atoms. So in the formula for water, which is H2O, that means we have here two atoms of hydrogen, and there is an understood one subscript here. So one atom of oxygen. Now, earlier in previous lessons, we have taken up the idea of molecules. That would be the number before the molecular formula. So in this case, there's an understood one here. So we're just dealing with one molecule of H2O here. Now, for most compounds, here are the characteristics. One, they are made of elements that are chemically combined. Two, they have the same proportion of their elements throughout the material. They cannot be separated except by a chemical change. And three, they may not be at all like the elements that they were made from. Also about compounds. So pure substance composed of two or more elements that are chemically combined. Compounds are formed by elements reacting or having a chemical change. A particle of a compound is a molecule. Elements do not form compounds randomly, and all compounds are formed from only the elements on the periodic table. Now, I have here two circles just making you remember the differences between compounds and mixtures this time. Compounds combine chemically forming molecules. On the other side, mixtures not chemically combined. Compounds combine in set proportion. Mixtures can combine in any proportion. And compounds, again, separated chemically. Mixtures, they are separated physically. Now, in this DI on mixtures and solutions, there is an associated work or assignment in Google Classroom. So here, for instance, if I click on this, this is what you have, a set of Google Slides. So I made sure that I created individual copies for you, dear students, so that you can edit it and put in your answers. So here, on the first slide, it's just again the three icons that would kind of describe how we are dealing with our lessons, usually in Google Classroom. I will be adopting some experiments or challenges from Let's Talk Science, and of course, this replaces Blackboard. So we are now into Brightspace, which is another learning management system. In any case, the second slide would be, so let me just be on the presentation mode. So as always, you're not new to this. I want you to just fill out this Google slide, like on what you know. So what do you know about atoms and elements? Now, what do you want to know about atoms and elements? And what have you learned about atoms and elements after going through this assignment? Now, again, this is a drag and drop feature of the assignment. So If you think cannot be easily separated, that would be under solution, then you put it here. Or this box here at the bottom, you put it on the proper column, okay? Again, a sorting slide here. So you have some examples on the right side. Look at the list of these mixtures and solutions, then sort them correctly into the correct category, whether they are mixtures or solutions. Identify it. So I want you to look at each picture, identify if it's a solution or a mixture. So again, drag and drop. Web search. You can use this website. You're free to use other websites, of course, to complete the questions below. So what is a solvent? What is solubility? What is a solute? What is a colloid? What is an example of a colloid? Now compare. So this is now a Venn diagram. So mixture. What is distinct or unique about mixtures? What is unique or distinct about solutions? Now, of course, the one in the middle, what do they share in common? Okay. Now look again at the pictures below, then answer the questions here. Now, you might be missing Bill Nye. I hope the answer is yes there. So check this out. Again, phases of matter. This would be a short video clip, and then on top of the, so let's try and see what happens here. So if I click on this, so a short clip about that, right? And then of course, whenever you are viewing a Bill Nye video clip, you know the drill by now. We always come up with some sort of a video clip form that you needed to turn in. So this would now be the expectation, okay? So that's the end of our short DI, okay? So that's it for now. Thank you again, and looking forward to the next DI with you guys. Bye-bye. Ciao for now.